not buying that. Do you do the square root of 980 or negative 980? What's the square root of negative 980? What happens if you do? You can do it. What kind of answer do you get? Not the right word, but
Imaginary.
that's the right word. Imaginary. It's an imaginary answer. So two things happen here. As you can pretty much be sure, there's going to be some problem on that first test where you'll get a negative under the radical. What you do not do is go, oh, I got a negative under the radical, why don't I just get rid of the negative sign? That way my calculator can work. That's not what you're supposed to do. A negative under the radical means one of two things. It means either you have made a mistake somewhere, which would be, in this case right here, the mistake was we had acceleration and displacement in opposite directions. What physically this represents is you let go of the rock and you're trying to time how long it takes to drop 50 meters and the rock goes that way. This would be a situation that there's either a mistake or it cannot physically happen. So getting rid of the negative sign means that I'm just assuming my mistake was I got a minus sign in the wrong spot. You're ignoring the possibility that it is an impossible problem. So let's go through and see if we can find an impossible problem. Back to the rock. The rock is thrown upwards. At an initial velocity. No, actually, an initial speed of, let's make it 20 meters per second. How long until the rock is is 15 meters above the point of release? I have had issues. I had a student who was from Mexico City. English was not her first language, and whenever I said how long until, every time she saw the word long, she was thinking distance or displacement. I probably out of habit, I'm gonna write something like this and assume that you understand it's time. If you have an issue with that, just because of the language barrier, English not your first language or whatever the issue is, just let me know. I'm gonna try to change that, but I just know how I write tests, and there's a good chance I'm gonna say how long in reference to time. So how much time until the rock is 15 meters above the point of release? So like any of these problems, we'll start out with writing down the big five and what we know. Displacement, initial velocity, final velocity, acceleration, and time. So what do we know?
Initial velocity.
What's the initial velocity?
0.
Ooh. You think
I mean,
about while it's still in the hand?
20 meters per second.
You just established something. What did you just establish?
Direction.
Keep going.
It's positive.
positive, which direction is positive?
Positive, yeah.
Yeah. By saying 20 meters per second here, you have now established up is positive. If you get really confused about that, you might want to, first thing you do before even writing down this stuff information is decide which way is going to be positive. Some people like the comfort of up always being positive. That's not necessarily the most convenient way of doing it, but it is a legitimate way of doing it. Especially when we get to chapter 4, up being positive all the time is not, you potentially are quadrupling the amount of math you have to do. It's in the first 3 chapters, it's not that bad. Chapter 4 is when it really makes a difference in terms of how much work you're gonna do. All right, what else do we know?
Displacement,
Is
15 meters.
positive or negative?
Positive.
All right. I'm sure that one can be seen better. We got one other piece of information.
Would it be acceleration,
Is
gravity, so 9.8 meters per second? In this case, negative, would it go negative?
which way is acceleration due to gravity?
Yeah.
Yep. And Jacob wanted us to be positive. So negative 9.8. If you did positive 9.8 there, you would get an answer that was, you would get a real answer. Just, it would be wrong. All right, so I want to find time. Which equation do I use?
Hold on, I'm confused as to why. So before it was positive because our displacement was positive? Is that
Yes.
what you were saying the first time?
Yeah, because the rock went down, so the displacement is downwards. And as soon as Craig said 50 meters, he established down as positive.
So now our displacement is positive, and how come?
Because it's thrown upward.
Yeah, the first problem was dropped, this one is thrown.
Okay.
Did you want down to be positive again?
No, I was just relating the two.
Okay. All right, so which equation to find time?
Fourth equation?
Which one's the fourth one?
BF squared equals initial plus.
There's no time in that equation.
Oh, I was doing it for final velocity.
If we had done, if we had done that, we could have found final, it actually would have found final speed, and then we would have to think through the
I
sign.
thought you'd ask for that. I don't know, we didn't tell.
I wanted to shoot for time specifically first, although there are times in which it is convenient to do that first and then solve for time, because we're gonna end up with a quadratic here. But we need to go through it because you'll be dealing with quadratics in this course. Is it the first one? Is that what I heard?
Initial velocity plus acceleration.
Trouble with the first one is I don't know VF or T. I'm solving for time and I don't know VF, so I want the equation that doesn't have VF in it.
Third.
The delta S equals,
The initial and the 1/2 acceleration. Yeah.
so VIT plus 1/2 AT squared. All right,
Correct, yeah.
this is to do it in one shot. We could have found the final velocity first and then we could have used another equation to avoid the quadratic. There are some dangers doing it that way. As long as you can think through the problem, you're okay, but in panic mode, I'd recommend this route. So I have 15 is equal to 20t plus 1/2 times the acceleration. So that would be minus 4.9 t squared. 4.9, that's half of 9.8. It's minus because my acceleration is negative. I'm gonna put in the intermediate step that I just skipped. So plus 1/2 times negative 9.8 t squared. So 15 equals 20 t minus 4.9 t squared. This is a quadratic equation. So more than likely, we'll be using the quadratic formula. A number of years ago, I was tutoring a high school student when I was still in Charlotte, and whenever faced with a problem like this, he would always complete the square. He did not use the quadratic formula at all. In essence, he was deriving the quadratic formula every single time. But, you know, it's legitimate, just longer. So if I want to solve this using the quadratic formula, what do I have to do? Louder, please. Yeah, well, in essence, if we did it that way, we're deriving the quadratic formula again. What is the quadratic formula? All right, I'm saying quadratic formula is assuming that all of you have dealt with it at some point in your math career. Is that a fair assumption?
Yes, but it's better now.
Okay. Still, I make sure that everybody at least has seen it.
Yes.
It's b plus or minus the square root of b squared minus 4ac over 2a.
The first thing you said was b?
Yeah.
Negative b. But that's, so ultimately, whatever letter you're using, negative b plus or minus the square root of b squared minus 4ac over 2a. Now, because this is physics class, that equation will be provided for you if you need it. But what are a, b, and c? And by the way, if you want to torture yourself, there are videos out there of people singing the quadratic formula to the tune of Pop Goes the Weasel. I will not do it to you, but you can do it to yourself, as unfortunately I did to myself several years ago, and it goes through my head every single time we get to this point in the course. So anyway, what are A, B, and C?
So b squared would be time squared. B would be time, and C would be, is that right?
No. A, B, and C are gonna be numbers. Time is a variable here, so technically in this case, we'll end up with T equals, that's where time shows up. If AT squared plus BT plus C equals 0, then time is equal to that. What we need to do is we need to set it equal to 0. I have seen way too many times people will factor out T here, and then at that point you're pretty much sunk because that's the wrong technique. We need to get this equal to 0. And the way we do that is I need to get everything over to the right-hand side or the left-hand side. It doesn't matter which way you go. Personally, this is just a personal preference based upon childhood scars. I like the coefficient of time squared to be a positive number, for whatever reason. So I'm gonna take everything over to the left-hand side. So I have 4.9 t squared minus 20t plus 15 equals 0. That's my A, that's my B, and that's my C. C is for constant. Or the third thing. So time equals negative 20 plus or minus the square root of negative 20 squared minus 4 times 4.9 times 15 divided by 2 times 4.9. So this becomes 20 plus or minus the square root of 400 minus whatever that is. What is this? Just shy of 300.
$270.
Say it again?
270.
270 over 9.8. Now the number that is under the radical, that is known as the discriminant. The vocabulary is not particularly important other than the fact that at various times I will say, what is the discriminant? When I say what is the discriminant, I'm asking for this number right here. And that could very well be misspelled. But we will pretend it's spelled correctly for the moment. And I think I'm off camera screen there, so let's mosey back over here. All right, so we have time is equal to 20 plus or minus the square root of 400 minus 270, which is 130, divided by 9.8. And what are the two answers?
For the negative, would it be 18.83?
Say it again.
For the negative, would it be 18.83?
Did you divide by 9.8? Yeah, that's something got off there. Should be something around 1 second and something around 3 seconds. When you typed it in, Amy, did you just type it in as one line?
No, I put it in, yeah, but now I'm putting it in parentheses.
Ah, yep.
For the positive, would it be 3.20?
.87. All right. Anyone else agree with this, these two? Got it, okay. So, there's two answers. What's the correct answer? Or what do both answers mean? There is some physical meaning to them. All right, someone describe to me what's happening in the problem. Physically, what is the problem talking about?
Throwing a rock up,
Okay,
and then it coming back down.
okay. So what do my two answers mean?
I'm assuming that the 3.2 seconds is, it's so it's going past the 15 meters and then it's coming back to the 15 meters?
Yeah. So the 3 seconds is on the way down. Because you throw it upwards, it's gonna hit the first time it's on the way up, the second time it's on the way down. So we do have two answers. So the answer to this question actually is 3.2 seconds and 0.87 seconds. Because there are two times when this happens. Questions, because I'm about to change the problem slightly, and we'll get very different answers. Hopefully this is enough contrast here. All right, I'm gonna change the problem slightly. So it's thrown upward initial speed of 20 meters per second. How much time until the rock is 15 meters below the point of reference, point of release? So imagine you're standing out over a cliff, you throw it up in the air, and then it eventually ends up 15 meters below. What changes? I guess we started here. What changes here?
Positive direction.
The positive direction changes? I was trying to figure out what you said.
Yeah, that's what I think.
So if we made the positive direction downwards, we're still left with what changes here?
Yeah,
Displacement changes.
All right, so I feel like there's two questions going on right now. Amy, you said acceleration, what did you mean?
It would turn into positive.
If we made down positive?
No, like, because you change it to below the point of release, it would go, your acceleration would become positive 9.8.
The acceleration is still downwards. So if you're keeping up positive, acceleration does not change. For the sake of this, let's just make up positive, just so that we're all working on the same problem here. You could change the direction to positive if you want, but for the sake of ease at the moment.
yeah.
Up is positive, acceleration is still downwards regardless. Ian, you were saying something?
Displacement, it would end up being negative 15.
That's the one change right there at this point. Which means that this 15 becomes negative 15, negative 15, negative 15, negative 15, making that positive. So instead of 130, it is now 670. And again, we will have two answers. They both have physical meaning. See how much actually got picked up over there. Yeah. Well, presumably someone watching the video at home will. They got this far, they should be able to do the rest of it. So the two answers are,
20 plus 4.68 and 20 minus negative 0.60.
looking for a final answer. 4.68. And
For the minus, I got negative 0.60.
0.60. Okay. Same move there, all right. Anyone get something different and feel like they did it correctly? James?
I keep putting in 4 times 4.9 times 15 for the 4AC there,
Right?
and I'm getting 294 and not 27.
I was getting the same thing, but I wasn't.
You know, you get something different, feel free to share earlier. So
I wasn't sure if I was
294.
doing it wrong.
So this right here is 294. So that changes some of the numbers for the last problem. The process we went through is correct. Apparently there's a mistake somewhere. So this becomes 694. I assume that's gonna affect these. Or the person who got 270, did you wanna make a stand and say that the 294 people are just crazy?
That changes it for 20 plus 4.7.
Alright, so how are you getting 20 plus 4.7?
No, but 20 plus 1 is 4.7.
Oh, I got it, 4.7, sorry, I misunderstood when you were talking last time. And negative,
Negative 0.64.
okay. What do these two answers mean? Or first off, which is the correct answer? Okay, what does the negative answer mean?
Is that when it's below the point of release?
Not below. Let's think about what the math is actually solving here. So if this is negative 15 down here. It depends on what point I want to solve it. That's probably good enough. So we have our starting point right here, and the object is being thrown. And the question is, at what time is it at negative 15? Well, negative 15 is there, so that's the 4.7 seconds right there. But the math doesn't know. You're plugging into an equation, it sees a quadratic here, and you're trying to find 2 points. That's the negative 0.64. Not below, but before. It has no idea that the problem starts here. The math thinks this thing is just an infinitely long parabola, and it's just trying to find 2 times. Now, one thing this answer does tell us is that we've done something right. Because it was initially thrown upward, I would expect that the positive answer is going to be larger in magnitude than the negative answer, which it is. If the negative had been a bigger number than this, that would have been, or the absolute value of the negative number is bigger than the positive number, that would have been an indication that something went wrong. There's probably a minus sign in the wrong spot, if nothing else. My questions are here before I change the problem slightly again. All right, so let's change it to, let's go back to above. And let's make it 45 meters above. So what changes?
Displacement
Becomes,
45.
so that's 45, that's 45, that's 45, plus 45, that becomes 45. So what's our discriminant now? Just one part under the radical. Is it too cluttered over there? The discriminant would be 20 squared minus 4 times 4.9. Times 45. That's the discriminant. Would have, surely somebody has it.
Negative 482.
Negative 482. Anyone else get the same thing?